Hello, everybody, and happy Friday to you. Welcome to Ask Math Anything. What do? Well, you just ask math, and I say anything. That's what we do every single day for about 1 hour. If you're new here, welcome. This will be different from the usual math classes that you've seen because you drive the math class, and I'm looking to see what you're interested in today. And if you've been here before, thank you for joining us again. It's been quite a lot of we've done quite a lot of these live streams now since we began in the middle of March. It's hard to believe that it's almost the middle of June. And in fact, that means that school is also almost done. Or maybe it's even done for some people already. Talk about Novid, Jacqueline, so you're curious. I mean, you may or may not have noticed that the app that I've been building to try to help stop the spread of COVID-19 had a version 2 update earlier this week. So if you have tried the Novid app recently on your iPhones, for example, you'll be even able to use them to measure how tall you are, because there's a button on there now where you can measure the distance to the nearest iPhone or the nearest Android phone. All right, but let's talk about math first, and then we can talk some things about Novid. Actually, let me open up what we've got here with my moderation team. And let's see, what kind of questions do we have today? Oh, Pietro has asked, you have a math competition on Monday. Can you have my blessing? Here's what I'll say. You don't need that. I would say that if you, actually, based on the kind of questions you've been asking, it sounds like you have a lot of math in your head. I think the most important thing you need to know is you need to have confidence in yourself. And I'm sure you're very good. Right? I mean, you should always go towards things, whether they are math contests or athletic contests or any contest, with the idea that, you are prepared and you are going to have the confidence to go and do your best. And that would be, I think, what you need the most, is to know that you have it in you fundamentally. It's not that you need it to come from me at all. More questions. What else can we do? Eric Feng, I must prepare for a test. Help! Yeah, just learn how to think is what I would say. What we've been doing in all of these live streams is just thinking. And as we learn how to think, there's nothing you'll ever be afraid of. You can always reason your way out of it. And now we probably have some interesting questions that we can start to talk about. That's interesting. Let's see. Oh, some of these are interesting. Some of these are also complicated. Oh, Leo Z. Why does order of operations have to be so complicated and not just parentheses first? You have an interesting idea. What you have said is, forget about this stupid order of operations stuff. Let's just write all the parentheses. For example, if you wanted to do 3 plus 4 times 5. Whoa, what happened to my screen? One moment, it looks like my writing became super small. I'll fix that in a second. Just a second. We'll take this. Zoop. What happened now? Where'd it go? Here we go. And what this is showing is that something's a little fishy with the writing. Now there's something I'm not buying. Something went a little bit weird with the writing. Let's do this. We'll do this first. But now what I'm more curious about is what in the world just happened with how the writing is going onto this screen. One moment, please. That looks fine. You're about to see me start to do some computer stuff. Just a second. That's what happened. Hopefully that's an improvement. We'll see. Okay. Yes, this was Linux. So we just made this thing bigger, and let's go back to this. Yes. Interesting. For whatever reason, it can't seem to find that. We're going to take this out and put it right back in. And if that doesn't help, we'll be fine. We'll make do. This is what I mean by just figuring things out. Things don't always work in the world. We'll do our best with this. And what is that thing? Yeah, it's fine. Okay, whatever. We'll make do with this. Okay, let's continue. There was no signal again just because I pulled out the plug of this particular computer. And for whatever reason, this computer is not sending out a signal which is at the full width. For example, if I do this, it just ends. So I can't seem to write on the far right edge. We'll figure it out. It's okay. Okay, right. But so this particular question was about order of operations. Like with this 3 plus 4 times 5. How might you think about this? I guess you could think of this as saying that's just going to be 3 plus 4 times 5. And then we don't need to have any order of operations, right? We could just go ahead and say, whenever I have something like this, I'll do what's inside the parentheses first. And you could do that. The thing is that a lot of times in life, the times stuff is actually stuff that you put together more, that you put it together first more than you put the plus. I'm not sure why not that I'm not sure why. Actually, I'm sure why. If you think about it, sometimes people say, I have twice as much, I take like 2 of these things plus 3 of those things. Actually, that's a very normal thing for people to say. I take 2 of something and 3 of something else. But the word of, OF, is usually times. For example, if I have baskets of 20 chicken nuggets and baskets of 9 chicken nuggets, then if I have 2 of the 20 baskets and 3 of the 9 baskets, that's 2 times 20 plus 3 times 9. Obviously, chicken nuggets come in baskets, right? Let's pretend that they do. But I'm basically saying that somehow this notion of 3 of something and 2 of something else is very natural. It's very natural that you would think of lumping together the times first and then adding together. So that's actually why it makes sense to do times before you do plus. How about divide? Well, divide is sort of like times. Divide and times are just like the opposites of each other, so those would also seem to be about the same level of importance. And so I hope that helps to explain to people why it would actually make sense that you would do the times and the divide first, and then the plus and the minus. Now, if you wanted to say, but if you drew the parentheses, it would just be easier. If you write a computer program to go and try to what's called parse means understand what's written down. If you try to write a computer program to parse these kinds of expressions like 3 plus 4 times 5, it's a huge headache. It's actually it's not fun at all to go and say, hey computer, I wrote down some long expression of math. Go and figure out what goes first. Oh, it's awful. And at that point you'd say, I wish we had just decided to use parentheses. Then I could just tell my computer program, look at the parentheses and do what's inside first. But while we're on this topic, let's talk about some other ways that you could write the same thing. Sometimes you can think of the same thing as this. Does this picture make sense to people? If I just drew you this picture, would you know what we're supposed to do? Is that a proton? No, it is a plus sign inside a circle. But if you drew this, you'd be like, yeah, it's like a tree. A tree? This is an upside down tree. Actually, there's a joke that says this is how computer scientists draw trees. They draw the trees upside down. And the joke says it's because the computer scientist was indoors all day anyway and never looked at a real tree. I can say this joke because I'm also a computer scientist. So and I'll also say not all of us stay indoors all day. But computer scientists do indeed draw trees going down. Now, you could understand this to mean that, multiply these first and then put it together with a plus. That makes sense. And here's something that's kind of fun. It's like if you're thinking about this, the 3 plus 4 times 5 is what happens if you're kind of going through the tree in order. I'm actually just going through the tree in order, like from the left to the right. You see, I see a 3 plus 4 times 5. Now, there are other things you can do. I'm not sure if anyone has one of these weird calculators that uses RPN. Does anyone know what I'm talking about? There are some weird calculators. This RPN happens to stand for Reverse Polish Notation. Okay, and these reverse Polish notation calculators are actually often made by HP. So somehow a lot of these were used by HP calculators, graphing calculators. Now, reverse Polish notation is kind of interesting. Oh, I see that there are some people here who actually have HP graphing calculators. So if you use these reverse Polish notation things, there's another way you could write this whole thing. So what you do is you actually write, let me see if I can get this straight. I think you write 3, 4, oh wait, to make it less confusing, I'll write it in a vertical order. 3, 4, 5 times plus. If you go into your HP graphing calculator and you just type 3, 4, 5 times plus, that means the same thing. No parentheses needed. What does 3, 4, 5 times plus mean? Well, what it means is as you're reading this thing, you're like, okay, 3, how nice, I've got 3. Then I've got 4, then I've got 5. What are you supposed to do with all these numbers? Well, there's a times. So the way you should think of this is a sequence of instructions. And in fact, what they're doing is they're using something that's called a stack. You know what a stack means? A stack means it's a pile of stuff stacked up. So let's start putting things on the stack. You put a 3 on the stack. Great, there's a 3 on the stack. Think of this as the ground. See, it's the ground. It's a very, very, the big ground, whatever. So here's the 3. 3 went on the stack. The next thing that goes on the stack is 4. Hooray. But now 4 is squashing 3. All right, so 4 is on top of 3. Next thing that happens is 5. 5 goes on the stack. 5 is squashing all of them. And then the next thing you see is times. What does the times do? You can't put times on the stack. No, the stack is only for numbers. What happens when you get an operator, like a times, is you say, Stack Overflow. Now, when you get the times, you say times is something you do with two different things. So let's go and grab the top two things on the stack, 4 and 5, and times them. That's what it means. If I see a times, I will go and take the 4 and the 5 off, and I times them. 4 times 5 is 20, and I put 20 on the stack. So what's going on here is that if you see an operator, you grab the top two things, you operate on them, and you put the result back in. And then now, what's next after the times? It's plus. So you grab the 3 and you grab the 20. 3 plus 20, they go poof, they're gone. And 3 plus 20 is 23. That's it. So that's reverse Polish notation. Actually, it means that you don't need parentheses ever. You don't even need order of operations. You just asked, is there a way that we can have no order of operations and just use parentheses? Well, here is a way that you can have no order of operations and no parentheses at the same time. What's Polish notation? It's where you just reverse everything. Let's talk about, I'll talk about that in a moment, okay? This is reverse Polish notation, and later we can talk about Polish notation. All right? So now let me give you some examples of some horrible thing that you might have to do. You know, suppose somebody tells you, I'm supposed to do 3 times 4 times 5, whoa, that's a weird 5, 5 plus 6, and then plus 2, parentheses, plus 1 times 3. Okay, I just wrote something down. How would you try to write this down in reverse Polish notation? I'm going to try to do this. I actually don't use such a calculator, but let's try. I would do maybe 3 first, okay? And then I will have a 4, okay? And then I will have the 5 and the 6, and I'll do a plus, and I'll do a times, and I'll do a times. Then I will do the 2, the 1, the plus, the 3, the times, and the plus. Let's see if this worked, okay? I just wrote all of this stuff down. Let's see if this actually does what's going on. You see, what's going to happen is first I will get the 3, 4, 5, 6, and then finally an operator, right? So let's go and try to write this thing down. Here's my stack. My stack has a ground. That's the ground of my stack. Now I have a 3 on the stack, the 4 is on the stack, the 5's on the stack, the 6 is on the stack. Oh, and then a plus sign comes. When the plus sign comes, I take off the 5 and the 6, and I replace with 5 plus 6. This time I'm actually just going to write down what it is. I mean, I'm not going to simplify it. Now that I have 5 plus 6, next is a times. Oh, so I have a 4 and a 5 plus 6. So what that does, hey, I'll cheat this way. It's like 4 times 5 plus 6. Does that make sense to people? So I just took the 4 off, and now I have 4 and then 5 plus 6. The next thing that happens is another times. If there's another times, then I take both off. I do multiply them together, and I put it back, and that will actually make me 3 times 4 times 5 plus 6. The next thing that will happen is I'll go to the 2. And I'm just going to be lazy, so I'm not going to erase and move that somewhere. I'll say the 2 is on top on the stack. How nice. Then there's a 1 on the stack. And then when the 1's on the stack, then I do a plus. So I take off the top 2 things. When you take off the top 2 things, you just get 2 plus 1. The next thing that happens is there's a 3. Okay, so the 3 goes on the stack. And then after the 3, there's a times. So I take off the 3 and I take off the 2 plus 1. By the time I put them all back, I get 2 plus 1 times 3. And finally, I just take off the plus. Plus means grab them both, and you get the purple plus the yellow. And that's exactly what I wanted. The purple plus the yellow is exactly this thing over here. So this is this reverse Polish notation. In fact, if you get, yes, these all float. So this is a stack of like floating balloons or something like that. Okay? So if you look at this, you actually are able to do you can write down everything you're doing without using any parentheses at all, and without using any sort of order of operations. You might wonder what happens if there's a minus sign. If there's a minus sign, you basically take off like the 2 things on top of the stack, and you take the one that's below it minus the one that's above it. Skylar Schreier asked, are these from Poland? Well, this is reverse Polish notation. That means that they are to Poland. No, I actually don't know exactly where that background is. I'm guessing that Polish notation is probably from Poland. And what's so reverse about this? What reverse... Oh, and actually Michael Xiang seems to like this. This is actually a great way to calculate numbers with a calculator. If you get used to it, you just go you just hit them all, and then you press these operators, and it's like, it's done. It's really nice. But there's something else called Polish notation too. Reverse Polish notation is where the operators come last. Polish notation is where the operators come first. Poland reversed is DNA lop, says Sujin Xu. You're funny too. But so let me just explain, what's the difference, right? In normal notation, there's a name for it. Normal notation is called infix. Normal notation is where you write 3 plus 4. But when you do this, you need to use parentheses, because you just somehow you put the operator in the middle, and when you put the operator in the middle, you have to say like what goes first and what goes second. Then there's something else called postfix. Postfix is 3, 4 plus. That's where you put the operator post. It's called infix because the operator, the thing you're doing, like the plus, that's in the middle. It's in. And postfix is at the end. It's post. And that's what we have just been looking at. Reverse Polish notation is postfix. But if you can guess, then there should be something else. There should be something called prefix. Can you guess how you would write 3 plus 4 in prefix? I wonder if you can guess what it would be. If infix is 3 plus 4, if postfix is 3, 4 plus, yes, that's right, Brian Lee, prefix is plus 3 and 4. And I guess you might call that Polish notation. Maybe? I'm not really sure. I've never really used it. But if I wanted to write this entire thing in prefix, I could do that. What would it look like? Let's just do it for fun. All right. I'm not really used to doing this, but let's just go and try. If I want to prefix this, I'm like, well, there's going to be a times going on. Okay? And the times is going to have to times the 3 and the 4. So I'll do times the 3 and the 4. Oh, let me show you how I would actually do this. I'm like, there'll be a times somewhere. And I'm going to times the 3 and the 4. But oh no, there's another times. So I'm going to times the 5 plus 6. 5 plus 6 is this. I'm going to use a different color so it's clearer to people what I just did. Do you see what I just did? What I said is I already got 3 times 4. That's over here. That's the 3 times 4. This is the 5 plus 6. And I times them. It actually makes sense. It's like I did 3 times 4 and then times the 5 plus 6. And that's why this green chunk, whenever this gets evaluated, that's going to become 5 plus 6. That's going to become 3 times 4. And I'm going to times this and this. It's like that. Oh, there's a plus. Okay, so then I need to do a plus of the other thing. It's going to plus this thing together with this thing. And this thing down here is supposed to be 2 plus 1 times 3. What's that? That's plus 2, 1. That's 2 plus 1. Oh no, I need more space because it's times 3. So I'll do plus 2, 1 times 3. Did you see how I did that? I basically just went and I said, I want to take this thing that I've written here in white and encode that in this kind of prefix notation. So this is just showing you different ways that you could try to write down arithmetic without having to use any parentheses. And This RPM you can actually use on a real calculator if you just get one of those HPs. So I hope this was somewhat interesting to you. This is not what you're usually used to thinking about, probably, but it is actually possible to do arithmetic with no order of operations and no parentheses. Okay, what is the question? I'm late. That's what we're trying to figure out right now. Although there's something else I'm not completely pleased with, which is that I get the sense that my video quality that's coming out here is not great. And I'm wondering if there's something wrong. Well, I'm not wondering. I know there's something wrong with the way that this is being plugged into the computer. And there's something wrong with the way this is getting in. So if you don't mind, I'm not pleased with the way this is looking right now. I'm going to go and fiddle with the computer for one moment. First, we're going to take this guy out. After I take this guy out, now I'm going to put this guy back in. Okay. Computers are like that. Sometimes they're a little bit strange. So that one's correct. I'm going to go and do the unplug and plug on my actual streaming computer, and I'll be back in a second. All right. Is this any better? Do we have sound now? I see that my thing seems to be indicating that there is sound. So sound is back. Very good. Thanks for putting up with me. We're always trying to figure out what's going on. Next question, please. What can we do here? Yes, Susan, you're right. It's whack-a-mole problems. You fix the video, then the audio breaks. Right. I mean, that's how all of these things are. Oh, I'll tell you another funny joke. People actually often said that the American telephone network, what's called the landline telephone network. I don't know if you guys even use those anymore at home, but you know, like there's a phone which is like the thing that gets plugged into the wall, and it's supposed to be a pretty good phone. It's not just like your cell phone. It has very good signal. It's very reliable. That's called landlines. And landlines, the landline network in the United States was developed to be really, really, really robust. It was supposed to be able to withstand war. It was supposed to be able to withstand attacks. And in fact, what they aimed for is they aimed for a very, very high level of reliability. They aimed for what was called 5 nines of reliability. Can anyone guess what that might mean? Can anyone guess what 5 nines of reliability could mean? What might 5 nines mean? 45. Yes, 5 times 9 is 45. What kind of a reliability is 45? 45%? That's awful. That's an F. So that's probably not right. Oh, somebody says, maybe it's 5 ninths. 5 ninths is not much better. That's like 55.55%. It's still an F. But now I see there's some people who have an answer. It's 9%. Clearly this is the answer, because this is an A plus. No, you can't have that as a percent. Actually, what it is indeed you're right. It's 99.999%. That's like what 5 nines of reliability is. So this is actually, that's not a joke. This is true. The American telephone network is supposed to be built with 5 nines of reliability. Now the joke is when we started doing things on the internet. On the internet doesn't quite have 5 nines of reliability. Do you know what? And I don't mean the internet. This is not really a joke about the internet not being reliable. I mean all these computer things, like today's graphics or sound. Do you know what level of reliability all these computer stuff have? It's not 5 nines. 1 9? No. Computer things is 5 8s. That's the joke. The joke is computer things are 5 8s. And of course the joke is that you can have as many 8s as you want, but that's not going to help you because you're still missing that little bit, right? And in fact, that's what we just saw today. It's like somehow this is a joke. I mean, this is just a joke that says, if 5 nines of reliability is very good, how about 5 8s? Shouldn't that be good too? But unfortunately, no. The 8 kills you already. And so the situation is that what we just saw today is like that 5 8s of reliability. It usually works, but sometimes it doesn't quite. Okay, more questions. Oh, that's neat. Moonwatcher 123, you want me to do a math problem, and I want to do it too. You're asking, what is the smallest whole number that is equal to 7 times the sum of its digits? Smallest whole number that is 7 times sum of its digits. I think I already saw that there were some answers that popped into this chat. So I have a feeling that you didn't mean to ask whole number, because whole number starts with a whole. 0 is a whole number. And 0 is 7 times the sum of its digits. So unfortunately, the smallest whole number is just 0. But that's not a very interesting question. So let's not use that. Let's adjust the question, not whole number. Let's adjust it to positive integer so that we don't have an answer of 0. At this point, you can see that a 1-digit number won't work. Because if I took a 1-digit number and I times 7, it gets huge, so it wouldn't work. Like the sum of the digits of a 1-digit number is just the number. So then I see a lot of people have the answer already, but I'll be slow. The way I would think of this is, how about a 2-digit number? A 2-digit number is like TU, and I'll put an underline. Do you know what T stands for? T stands for tens digit. U stands for units digit. So I would say that the TU, that's equal to 10 times T plus U. And now if I need to know, like, how could it be that this is 7 times the sum of its digits, I have an equation. 10t plus u is supposed to be equal to 7 times the sum of the digits, t plus u. So these questions, you just now go and try to solve for t and for u. So I have my 10t plus u is equal to 7t plus 7u. I think we can do this. Subtract 7t from both sides, 7 times t, not 70. And I get 3t, subtract u from both sides, 6u. And if I divide by 3, t is equal to 2u. So any number for which the tens digit is twice the units digit, it'll be great. And that's how the easiest one is 21. But I see that people are listing all the other ones, like 42 and 63 and so on. But the smallest one that works is indeed 21. So that was nice. Thanks for sharing this question. These are always kind of fun, and the easiest way to go and solve them is indeed to try to think of what you could do to write down your number as an algebraic expression. More questions. I'll take a sip of my water while I look for questions. Good question indeed. I agree. Moonwatcher. I like the next question you gave. These are all kinds of these are digit puzzles, okay? I wonder if what you just did is you found the digit puzzles section of a book and you're just asking me all of them to see if I can solve them. Let's try. Because the good thing is, even if I can't solve them, we have enough people here watching that they can help me out. Okay. My twin lives at the reverse of my house number. That's neat. You not only have a twin, but they're also living at the reverse of your house number. The difference between our house numbers ends in 2. So let me write this down. Oh, and what are the lowest possible numbers of our houses? Okay, so there's a twin, and there's a me. And somehow the house numbers are reversed. So the house numbers are reversed. So here's like the house number, and here is the house number. They're reversed, okay? So they just happen to be reversed. I wasn't able to write the letters reversed. This is the best I can do. But so we've got the house and the other house numbers reversed, and somehow the difference is 2. Difference is 2. Okay. And the question is, what are the lowest possible numbers of the house? So first of all, if the number of digits is a 1 digit, we're in trouble. 1 digit house number? No way. Okay? Because a 1 digit house number, if you reverse, it's still the same digit. Let's try 2 digit house numbers. Does this work? Well, if they're 2 digit house numbers, we could have that the twin is in TU and U are in UT. Okay? But we have to remember what these are. These are actually 10T plus U and 10U plus T. Is this possible? We're about to find out. So if the difference isn't 2. Difference ends in 2. That's very important, because otherwise I was like, is this possible? So the difference ends in 2. Okay? So let's go and take these two things, and I guess we could try subtracting them and see what happens. So if I subtract these two, I guess I should just go and say, I don't know which one of them is bigger, but let's just go and say that the twin has the bigger house number because the twin's house number is higher up. Let's just say that, okay? It won't matter which one. We'll get the same 2 answers anyway. Big. This is the bigger. Okay? Then if I subtract them, the difference is equal to 10t plus u minus 10u plus t. Okay? And now if I go and try to figure this out, then I get 10t minus t is 9t minus 9u. Oh, that's nice. That's equal to 9 times t minus u. Now, I have to ask myself, how do I have 9 times something end in 2? And I want these things to be as small as possible. 9 times 1 ends in 9, 9 times 2 ends in 8, 9 times 3 ends in 7, 9 times 8 ends in 72. So in that case, this should be 8. Is everyone with me? So I need to have 8 here. And if that's going to be 8, and by the way, I shouldn't have a number here be like 17. 9 times 17 should also, sorry, I shouldn't have 18. If I have 18, 9 times 18 also ends in 2, but you can't have a tens digit and a units digit differ by 18. So I now know that the tens digit and the units digit differ by 8. And I see a lot of people have put these answers out now, like Amy Fan. It's 19 and 91. That seems pretty good. The 19 and 91, that happens to be different by 8. Like 0, 8, and 80 also differ by 8. Sorry, 0 and 8 differ by 8. But that's not so useful because these are 2-digit numbers and 0, 8 doesn't count. So that's how I get to the answer of 91 and 90. 91 and 19. And if you go and compare, yeah, it works. If you subtract these two, 91 and 19, the difference ends in a 2. What is the difference? Is it like 72? Oh, of course it's 72, because it has to be 9 times 8, 72. Okay, that was cute. Well done. What other questions should we pick? And thanks to everyone who pointed out, it's that the difference ends in 2. It's not that the difference is 2. Because if you look at this, you now see there's no way the difference can be 2. The difference is always 9 times an integer, and 2 isn't one of those. Wow, here's a question that I don't think I'll be able to answer, because this type of question, usually the answer is a lot of case analysis, but I want to just put it out here for people to ponder anyway. This question is by Emmanuel Carniero, asking a coronavirus question. The coronavirus question is, what is the smallest radius of a circle which contains 11 people, such that each pair of them is at least 1 meter apart. Containing 11 people. Where each pair is at least 1 meter apart. Oh, this is really interesting. I just figured out what was going on with my screen. I can fix the screen now. No, that didn't solve the problem. Okay, I haven't figured out what's wrong with my screen. Something in my screen is stretching. So this is like, as I'm doing any kind of a live stream or anything, I'm always thinking like, what's the deal? What's going on here? And what is so interesting is that when I write all the way out to the right edge of this, it doesn't quite go to the right edge for you guys. It just goes to here, right? So there's some kind of a transformation being applied to my screen right now. And that's also what's adjusting this graphics quality for people. So that's what I'm very curious about. It looks like this is all right. Huh. Filters. Crop pad. No, that's right. That's right. Okay. I'll figure it out another time, I guess. So basically, there's something happening with the stretch on this screen. And that particular stretch is causing it to look this way. Okay, we're back. Let's continue. So we want to solve this particular problem, and we want to know, what can we do? What's the smallest radius? So if I want to do this, I guess let's go and try. I'm not sure how easy or hard this will be. In fact, my hunch is that this is hard, because we need to first go and figure out how can you put down 11 people, right? How can you put 11 people in? And if you want to put them all kind of in a circle, if you gave me the question which was 7 people, I know what I'll do with 7 people. I bet that the answer for 7 people would be to do this, and then to make a circle around it. If you did this and made a circle around it, that would probably be the smallest circle that you could have that would have these 7 people. But now the problem is, what do you do with 11 people? If you want to put 11 people, it's like, how would I put 4 more people into this pattern? Not very clear. If I wanted to put 4 more people, I guess I might try to put 1 here, 2 here, 3, and I get 1 more person. But that doesn't help me too much. Maybe here. And then I would say just make whatever circle you can around these. However, unfortunately, if you do this, it's actually going to be very hard to answer the question exactly. So my answer to you is, it depends. Like these kinds of questions, you have to go and try a lot of different configurations. One way is this. My hunch is that you probably want to build off of the 7 here and put 4 on it in some way. And this way that I've put 4 on is probably not bad. What I would compare this way of putting 4 on is I would compare this one against this one. To me, these seem like the 2 reasonable ways that you'd put 4 on, and I'd see which one has a smaller radius. But I don't know the answer. And the reason why I don't know the answer is this is a case analysis problem, where you also need to go and check out a few cases. Let's draw a better picture. You have to check out a few cases just so that you know which one of them is actually better. This is more a case problem than an actual exact computation problem. Okay, what else should we do here? Other questions? I see that Vera Wang, you've asked a very interesting question about Bob the cat and meowing and changing colors. I think it looks interesting. The only problem is that it looks like it's a bit too many details, in the sense that I'm not sure that the hardest part of the question is solving the question as much as trying to communicate all the details to the audience. So I'm not sure we'll do that one today because somehow there's a lot of different things happening in the problem, and it would be a bit hard for everyone to understand the problem at the same time. But thanks for asking that question anyway. I like to usually choose questions that are easy enough for everyone to grasp right away, and then we can go and attack them. Okay? Oh, these kinds of questions. Danny Lam, looks like you gave me your homework. But I'm pretty confident it's not your homework because most schools are out of school, so I'm willing to answer this. The question is to simplify. simplify. X squared plus 3x plus 5 divide by x plus 3. As you want something like x plus c, where you don't know what c is, plus r, where I don't know what r is, divided by x plus 3. Okay, so this is a fairly standard homework style problem, but I want to talk about this because even if you've never done Algebra 2, you just do long division. This is, by the way, why long division even works in the first place. This is actually, like, a lot of times when you started learning long division, you were like, well, you just draw this thing that looks like an L shape. L for long, right? That's why it's called long division. You draw L. No, it's called long division because it's long. Anyway, but we just do this long division thing, and you just write down, I have x squared plus 3x plus 5. And you just divide by x plus 3. Now, when you do this long division, you just do it the same way. You say, okay, how many x plus 3's can I put in x squared? I don't know. It doesn't seem to fit very well. Let's put it all the way over here. It's like almost if I had the number 135 divided by 13. And you'll see that come soon. Okay? Let's first go over here. And let's say, well, I can take x times x plus 3. If I took x times x plus 3, that gives me x squared plus 3x. This is exactly what you do when you do normal long division. You just go and write something up there, and then you multiply that thing by the thing in front of the long division, and you put that there, and then what do you do next? You subtract. It's the same deal. And that makes sense because what this is saying is if I multiplied x plus 3 by just x, then I would get this x squared plus 3x, but I got to deal with the 5 somehow. How much, when I say I've got to deal with the 5 somehow, I got to subtract and say, how much is left? Well, 0 plus 5. And what do you do with the 5? I don't know. How many x plus 3's are in 5? None of them. So plus 0. If I do 0, 0 times this x plus 3 is 0, and you subtract, and you get 5. And so the answer is actually, it's x plus 0 plus the remainder is 5. 5 over x plus 3. And this is exactly the same as normal long division. And in fact, I'll even say, you know what happens if you took 135 and you divided it by 13? If you do this, 135 divided by 13, 13 times 1 is 13, subtract, then there's a 5, 0, 0, subtract, there's a 0. So if you took 135 divided by 13, what you find out is 135 over 13 is equal to 10. Wait, it's not 0. What did I do? 5 minus 0 is 5. 10 and 5 over 13. Does that look familiar? Hey, look, 10 and 5 over 13. It looks like it's the same. And it should be the same because if I look at what I did in the pinkish purple, I basically just did everything where x was 10. And so it's like 10 plus 0, oh, that's the 10. 5 over 10 plus 3, that's 5 over 13. So all of this long division, whether it's polynomial long division or normal long division, is very related. And that helps you if you're wondering, how would you remember this? You don't really have to remember it. It just makes sense. It's the same thing you're doing with division anyway. Okay, more questions. I'll take a sip of water as usual and look to see what do we have here that people have asked. I see some people said, he made a mistake. Yeah, it happens all the time. I make mistakes too. And so ultimately what we need to do is we need to make sure that whenever you're making a mistake, make sure you have almost 200 people watching you so that they can help correct it. Andrew Chow asks, do you watch YouTube? Well, normally, not really. I do watch this live stream on YouTube because while the live stream is happening, I get to see the preview of the live stream. So in some sense, I do actually watch YouTube every day for approximately 1 hour, which is this live stream. But other than that, I don't generally watch YouTube too much. One reason is because, as some of you know, I've got some other hobbies in this world, and those actually take up all the rest of my time. But I do think that, YouTube is pretty interesting. The fact that YouTube exists means that there are ways for lots and lots of people to be able to kind of let their ideas be known to the world. And I think that's an amazing time that we live in, that you can do this. Oh, do you approve of TED Ed? Yes, the TED Ed stuff is pretty interesting. Actually, I don't know if you saw, but there's a TED Ed collaboration which I was involved in. It has to do with flipping coins and getting heads and tails in a row versus heads and heads in a row. So I've actually worked with TED Ed before, and one of my lessons is actually in there. So I definitely will say the TED Ed stuff is really interesting. And the team behind it, the people who are actually making the TED Ed, they're really interested in mathematics and science. There's some fun people. I talked to them in New York back when it was easy enough to travel to New York. Let's see. Oh, I wonder what the answer to this question is. Claire Guo. Claire Guo asks, let n be a positive integer. You know how many problems in the world start that way? A lot, including this one. What are all possible remainders when n to the power 8 is divided by 17? N to the power 8 divided by 17. That was supposed to look like a dot, dot, dot. Dot, dot, dot. All possible remainders? What could we do? Well, I'll tell you what I would do. I would probably go and start trying to divide. Let's just go and find out what kind of possible remainders could I get with n to the power 8. Well, I guess I have to try all the different powers. I have to try n. Sorry, not all the different powers. I have to try all the different n's, like n equals 0, 1, 2, 3, 4, 5, 6. Is this going to be nice? Oh, here's a way that I can save some effort, okay? So I don't really want to do the whole thing because I'm lazy. Instead, what I'll say is that here's how I can get to n to the power 8. Here's what I'm going to do, okay? I'm too lazy to do this problem. This is too hard. But n to the power 8 is equal to n squared, squared, squared. So all I need to know is what happens to my remainder when I divide by 17 when I square it. And I'm going to do that 3 times, okay? So first I'm going to do this with n squared, and watch how this thing saves a ton of time. I see that somebody said, do not deny the ways of Po-Shen Loh. You should have said, do not deny the laziness of Po-Shen Loh. I will not ever want to do something like this where I have to calculate 17 things and take 8th powers. But I'm willing to square, okay? Let's try to square. I'm going to make a chart. So I have n. I have n squared. And I have somehow remainder mod 17, okay? I think we're probably going to need 2 screens to make this chart, just because 17 is a big number, so we'll have a lot of these. Those lines, they look straight, but they don't look like vertical. So hard. Close enough. Okay, got these 2 straight. Now let's see, what's the first n? The first n is 0. I know what 0 squared is, and 0 squared mod 17 is 0. 1 squared. Well, let's switch colors, because if we keep switching colors, it's easier for us to keep track of the rows. 1. Okay, I'm just going to do this as fast as I can. 2, 4. Remainder 4 divided by 17 is 4. 3, 9. 9 squared is, what do you mean 9 squared? No, 9. 9 has a remainder when I divide by 17 of 9. 4 gives me 16. Remainder when I divide by 17 is 16. That's nice. 5, 25. Help! What's the remainder when you take 25 divided by 17? 8? I hope it's 8. Please correct me if there are any mistakes here. Okay? 6. 6 squared is 36. Oh, 17 times 2 is 34. So that gives me a 2. Okay? 7. 7 squared is 49. I know that 17 times 3 is 51. And so this is 2 less than a multiple of 17. So it should be 2 less than 17, meaning it's 15. Right? The trick I just used here is that 49 is 2 less than a multiple of 17. And so the answer should be 2 less than a multiple of 17. So like 0 minus 2 is 15. Like 0 minus 2 is like 17 minus 2. Okay? Let's keep going. 8. 64. Help. Okay, I know that 51, we just figured out that 51 is a multiple of 17. So if I subtract 51, I get 13. Okay, let's keep going. Is that correct? Thank you, crowd. Having this crowd here makes it so much easier to do math. All right, 9. 9 squared is 81. Oh no. So if 51 was a multiple of 17, that was 17 times 3. The next one is 68. 68 is a multiple of 17 also, right? If 68 is a multiple of 17, if I subtract, 13. Look at that. I got 13 and another 13. Coincidence? I think not. It's not a coincidence. There's a reason why it should be. The reason is because 9 is the same as minus 8 when I think about things mod 17. So this 9 is actually the same as minus 8. I'll write 3 things there to mean that they have the same remainder. Okay? So the thing that's going on here is that if I have 9 squared, that's the same remainder as minus 8 squared. But minus 8 times minus 8, minus minus makes plus. So it's the same as 8 squared. So these two should be the same. And once you see that, now you know what's going to happen with 10. 10 squared is 100. Oh, but if 10 squared makes 100, okay, I could do it the slow way. 17 times 5 is 85. Okay, so if it's 85, 85 plus 15, okay? So it would be the 15, but it's not a coincidence that these are the same and those are the same, because 10 is the same as minus 7 mod 17. Okay, so everything reverses. It all goes all the way down with everything reversing. And here's how I'm going to write that down, okay? I'm going to write down what, like the 0 goes to 0, 1 goes to 1, 2 goes to 4, but also the flips go to these, okay? So let me write the whole thing down as a summary like this. Helicopter is coming overhead. So if I think about what I actually made, how can I get a 0? I can get a 0 from a 0. I can also get a 0 from a 17, but a 17 is just like, that's just 17. 17 is just 0. Now how do I get a 1? There are 2 ways to get a 1. You can get a 1 from a 1 and from a 16, which is the negative 1, okay? The next thing is 4. 4 comes from, I'm trying to think if this is the easiest way for me to write this stuff down. No, I want to do it a different way, okay? Scratch that, because I want to fit everything onto this screen so you can see what I'm doing. I'm going to write a new chart, which is what happens when I square, okay? And I think I need to use horizontal space for that. For that, I need to get more space. Let's clear this off. Let's just erase that line and write a different one. Now I've got myself a nice amount of horizontal space and a line that was too slanted. There we go. Now I've got this nice horizontal space, and I'm going to write down something like this. We have an n, and we have an n squared remainder. You might be wondering, why did I leave so much space here? I left a lot of space up there because I'm about to just go, well, it's 0, 1. I'll write the even ones first. 0, 1, 2, 4, 6, 8, 10. I need more space. The numbers are getting bigger. 10, 12, 14, 16. Oh, I could have actually not crammed it as much, but that's okay. 1, 3, 5, 7. Yes, it's crammed too much. Just a second. I'm going to make it less compressed. 0, 2, 4, 6, 8, 10, 12, 14, 16. Hey, that's about right, okay? And then the other ones will be 1, 3, 5, 7, 9, 11, 13, 15, and 16. So these are all of the n's. Now watch what I'm about to do. I'm going to just copy down what I have so far, which is that what happens when I take n squared? Well, I know that 0 squared made 0. I know that 2 squared made 4. I'm just not going to keep changing colors. I'm going to draw all the green ones first. 4 made 16. 6 made 2. 8 made 13. 10 made 15. What did 12 make? Remember, it's kind of mirroring, right? So what did 12 make? So 12 should make the same as 17 minus 12, which is 5. So that should make this number here, which is an 8. Okay, 12 should make 8. And I can even go trace back. It's like 12 made 8. So 14 should skip 2 more down and make a 4. And 16 should skip 2 more down and make a 1. Is everyone with me on this? I'm basically just writing down what happens as I'm basically reading down this table and then reading back up this table. And now let's go and fill in everything else. Well, now I'm going to fill in the purple ones. 1 made 1. 3 made 9. 5 made 8. 7 made 15. 9 made 13. And it's just going to reverse, right? It's just going to do a reverse. So if I see it's like 13, 13, 15, and then it's a 2, and a 16, and a 4, and a 1. Really? That's fishy. No. Something screwed up. So it should be 13, 15, 2, 8, 16. Wait a second. I'm not liking this. I'm going to look at this more closely. There's a mistake. So the 13 and the 4 should match. The 4 should not be a 4. These are mixed up. It should be 9, 4, 1. 9, 4, 1. And I think I saw someone on the chat saying this earlier, that I had them mixed up. Yes? Oops, 14 is 9. So what I just did here is I did a cross-check. The way I did a cross-check to make sure I didn't make a mistake is it's supposed to be nice and symmetrical. It's supposed to be even around the middle and just like symmetry on both sides. Okay? Now why do I do this? Watch. Now how do I make n to the power 4? What do? I just use this again because I know what happens to 0. The square of 0 is 0. I basically use the first 2 rows to build me the next row. Okay, this is the trick. Because like I know if I've got a 0 for n squared already, I square that. And I know that to square 0, it's just, I read it from the top, it's a 0. Squaring a 1 is a 1. Now what happens if you square a 4? Well, let's look for the 4. 4 squared gives you a 16. Okay, that's what that is. What happens when you square a 9? When you square a 9, what happened? When you square a 9, you get 13, according to the chart. What happens when you square a 16? When you square the 16, where's the 16? You get a 1. What happens when you square the 8? When you square the 8, let's look for the 8 up there. There's the 8. You square it, you get the 13. What happens when you square the 2? Well, that was easy. You square the 2, you get a 4. Next, what happens when you square the 15? Squaring the 15 gave us 4. What happens when you square the 13? Because that's what's the next one here. When you square the 13, you get, looks like 16. Okay, so I've just done this where I went up to here, but you know what? The question didn't ask what all of them were. The question asked what's the list of all of the different remainders I could possibly get. Is there a mistake? If it seems okay, I think this might be okay. All right, if there's a mistake, let me know. The question was, what are all the different remainders when I take n to the power 8? And look, the things over here, these will be mirror images of this. So what I can say is, same. Because I only care about, like, are there any new things, right? I only care what are the different things I could get as n to the power 4, because I'm going to square all of those. I just need to say, if I see a number appear twice, I don't even care anymore. Because I just want to know what are the different possibilities I could get if I square again. And when I look at that, I can say, I don't care about this one or this one. or this one, or that one. Because if I just want to know what are the different things I could get, right? If I figure out what happens when I square the 1, if I square the 1 again, it's still the square of 1. So watch how I saved a ton of work. Now n to the power 8. I just say 0 squared is 0. 1 squared is 1. 16 squared, oh, I can read from there. 16 squared was 1. Whoa, this is cool. 13 squared is going to be 16. So that means that the answers, what are the answers? What are the different possible remainders that you could have if you took n to the power 8 modulo 17? N to the power 8 modulo 17, the only possible remainders are 0, 1, and 16. There are only 3 of them. And now I know why. Okay, you gave me this question, I know why. It's because there's a famous theorem. This one I don't have the time to prove today. It's called Fermat's little theorem. Fermat's little theorem tells me that x to the power, let's not call it x, n to the power 16 is congruent to 1 mod 17. So actually, since you wanted n to the power 8, it will be all the square roots of 1. Oh, wait. This is not true. This is true for every non-zero n. For all n which are not congruent to 0, mod 17. I don't have the time to go into full detail on this stuff because this happens to be actually the whole content of our number theory online course. We spend a lot of time going into this. It's too deep to do right now. But for those of you who want to know, maybe you took the class, maybe you want to know what's going on, that's all it is. It's just that the non-zero ones have to square to 1. So what you just saw here are 0 and the square roots of 1, which are 1 and minus 1. So that's what's going on. I forgot the 4. Oh, I forgot the 4. How did I forget the 4? Oops. But that's okay. 4 squared is 16. It's still okay. I still got super excited. The way I got super excited is like, oh, it's 0, 1, and minus 1 because of Fermat's little theorem. And that's how it all works out. But what you just saw here is how a lazy person would go figure out all of the answers without having to do all the 8th powers. Thanks for asking the question. And thanks for joining us this week. We are indeed over time. So since we're over time, I guess I'll say I'll be back tomorrow evening. It will be 8 o'clock p.m. Eastern time. That's our weekend show. The weekend show this time we'll be doing a collaboration with another amazing group. But that's all for the normal week. So I hope all of you had a good time. I hope you have a safe end of the week. Have a good dinner or breakfast wherever you are. And I'll see you tomorrow.